Video assignment C2, Rates, Applications. Learning outcomes for this lesson. Following the completion of the workbook assignment and the in-class activities, the successful student will be able to 9. Calculate and interpret velocity and acceleration in an application problem. So we're going to take our differentiation rules and apply them in some setting. Advice for mastering the learning outcomes. First point, when you are working with application problems, always be aware of your units. What are the units for your variable and for the original function? What are the units for your answer? So always be aware of units. For motion problems, first, do not assume that the function you are given is the position function. You have to read the problem carefully to see whether it's the position function or possibly something else. Also, do not assume that your scenario fits the kinematic equations if you've seen them before. The kinematic equations assume a constant acceleration. That may or may not be the case depending on the details of the scenario. So again, read the problem carefully. Also, any word problem should have a word answer. Formulas for motion problems. S equals f of t is the position function. To get the velocity function, you take the derivative of the position function. So the velocity is f prime of t. When you take the derivative of the velocity function, you get the acceleration function. When you take the derivative of the acceleration function, you get the jerk function. And I have to say, I've never actually used that for anything practical ever. The jerk function, that is. And then there's not really a symbol for it, but the speed is the absolute value of the velocity function. And so you get the speed from the velocity by taking the absolute value. So speed can't be negative, but velocity can be negative. The velocity is positive when the object is traveling in the positive direction, and the velocity is negative when the object is traveling in the negative direction. And essentially, that is an assumption that we make about how our model works. And then FYI, the position function does not necessarily represent the total distance traveled. It might or it might not, depending on the situation.